Here we are given a function f of x equal to cos x plus cos root 2x. Then the number of values of x for which this sum cos x and cos root x together will attain its maximum. Cos x we know it runs between -1 to +1. So the highest value of cos x is 1. Right. When you can clearly see when x equal to 0, cos x is also 1, cos root 2x is also cos 0, which is equal to 1. So when x equal to 0, the sum is actually equal to 2. Okay. Now, let's take the case of cos x. Cos x is 1. When is it 1? When x is 0 or 2 pi or 4 pi or 6 pi, every 2 pi. Right. Every plus 2 pi, this one will attain its maximum. What about cos root 2x? Cos root 2x will attain its maximum whenever root 2x is a multiple of 2 pi and is a multiple of 2 pi, right? Whatever is this one, if this together is either 2 pi, 4 pi, whatever. Okay. So what does that mean? X is a multiple of root 2 pi, right? If x is a multiple of root 2 pi, then this cos root 2x will be equal to 1. Right. Whenever, so for example, n is 1, then root 2 x equal to root 2 pi. What does that mean? Root 2 into root 2 pi. Then that becomes 2 pi. Then root 2x will become 2 pi. Then this will be maximum. What does that mean? Root 2x, cos root 2x is maximum when x is, firstly when x is 0, then secondly, then root 2 pi, then third one, so third one, 2 root 2 pi, 3 root 2 pi, 4 root 2 pi, likewise. So cos x is maximum when x is a multiple of 2 pi. 2 pi, 1 2 pi, 2 times 2 pi, 3 times 2 pi, 4 times 2 pi, like this. Here root 2x, cos root 2x is maximum when x is either root 2 pi or 2 root 2 pi or 3 root 2 pi or 4 root 2 pi. So together root 2 into x will become 2 pi. Root 2 into root 2 pi will become 2 pi. Root 2 into 2 root 2 pi will become um, 4 pi. Root 2 into 3 root 2, that is 3 into 2, 6 pi, likewise. Okay, so cos root 2x will attain its maximum whenever x is root 2 pi or 2 root 2 pi or 3 root 2 pi or 4 root 2 pi, etc. etc. You can clearly see cos x is getting maximum at an every even multiple of this thing, right? Integer or even multiple of pi. Here this is getting maximum at an irrational multiple of pi, right? So there is no way they can be together maximum at the same time, because this is all will get root 2 multiples. Here we will get 2 multiples. They will never coincide, right? For example, if it is something like, if we are getting like some 3 pi, 6 pi, 9 pi, whatever, if we are getting something like this, then there is a chance of coincidence, right? But here in both the cases, one is a multiple of even integers, the pi is a multiple of even integers, the other is a multiple of irrational numbers. So these cycles they will never attain at a place where both of them will attain its maximum. This one will attain its maximum at even multiples of pi. This is attaining its maximum at irrational multiples of pi. So there is no place they will ever attain. Even if you wait for 100 years, they will never attain their maximum together. This one will is attaining maximum at multiples of root 2 pi. This one is attaining maximum at multiples of 2 pi. So they will never coincide. The only time that they attain together is when both are 0. For example, the graph will look like this. Okay, so this one, this orange one is cos x. Okay, roughly 6.2, then 12.4, whatever. So 6 is 2 pi, right? 2 into 3.1. This is 2 pi. This is 4 pi. Likewise, this is 6 pi, whatever. Okay. So, and this one is attaining maximum of root 2 pi. Then 2 root 2 pi, 2 root 2 pi, 3 root 2 pi, 4 root 2 pi, likewise. So these 2 points, they will never coincide. The only point of coincidence is this, when both are 0. Otherwise, one will attain its maximum at some time, another will attain its maximum at some other time. One is a multiple of even numbers, other is a multiple of irrational numbers. So this graph, this highest points will never coincide ever again. Right. The LCM, basically, we are trying to look for an LCM of rational and irrational numbers, integer multiples, which will never happen. Right, guys? So, the correct answer is only time. Function, these two attains maximum is only once. That is when x equal to 0. Correct answer is B.